Good morning. Welcome back. So today we'll be discussing chapter number 9, and chapter number 9 is a brief chapter. In this chapter, we'll continue our discussion about structured data type. If you remember, in chapter 8, we talked about arrays. Arrays are structured data type, and we transitioned from simple data type to structured data type. So the next few chapters are all about structured data type. Let me make sure you have access to my PowerPoint. All right, so this chapter here, like I stated, when you read the material, it's not a very long chapter, but the concepts are going to trickle down to chapter 10 as well, which is object-oriented classes and objects. So this will help us to make a transition from arrays directly to classes. So this is like in-between chapter. So we'll learn about what are the structs, the other name is records, and how do we do operations, how do we actually manipulate the data in struct, and then also the relationship between struct and functions. How do I pass a struct to another function, which I'll be demonstrating to you. And then this chapter also compares arrays and structs. And what else? How do I use arrays as structs as well and create an array of struct items? And I'll be demonstrating all those things to you just in a bit. So struct is a collection of fixed number of components accessed by name of different types. So this is the key here. I just want to highlight this one here. If you remember when we looked at the definition of array, array is exactly the fixed number of components. Just if you remember, collection of fixed number of components, just like arrays, and we call them elements. Here we call them members in case of struct. But you can actually have different types of members. In case of arrays, if you declared an array of integer type, all the data must be of that type. And if you declared an array of string type, all the data must be of the string type. So in this particular case in struct, we have an option to declare different types of data within a struct. So this will give us a little bit more flexibility. On top of that, we can actually declare an array of struct type as well. So which makes it much more useful. And I have 3 demo files available on the Canvas site. So I'm going to run just one of them just to save time. But if you look at the demo files on Canvas, you can find various kind of operations I'm running in those demo files. So I'll be showing you that one in a few minutes. All right, so struct is a definition, not a declaration. So this is important. What it means is when you actually create a struct, no memory is allocated. It does not allocate any memory at that time because it's simply a definition. It is like an intention that you want to create something, but nothing was created at that time. And that's what it means, no memory is allocated, that no physically, nothing has been created yet until you create a member of that type, which we'll see that in a few minutes. So must declare a variable of that type to use it. That's how you can allocate the memory. And that's what you see right here underneath, which I'll talk about it. So let's say you want to create a struct or a record, which is house type. So inside the house, you have a variety of different kind of members. You have what is the style of the house, how many bedrooms are there, how many bathrooms, do you have car garage, the year built, the price of the house, the taxes you pay on annual basis, the square footage. Notice that this time around, we have few items which are integers, an item which is a string, double, and we can add many different types. So when you actually define this particular struct house type, the keyword must be used struct. That's a keyword. So you start a curly brace, end with a curly brace and semicolon. So this is how it is done. And in fact, when you go to chapter 10, hopefully next week, and you'll see the classes are declared or defined in a similar fashion as well. So once this is done, we have this intention that I want to create this house type, and house type can have these members. And then once you are in a function underneath, maybe in a main function or a different function, then this is your name of the struct house type, which you have defined here. These are the members. Then you say, I want to create new house. When the new house variable is declared, that's when the memory is allocated for all of these members inside. So this needs to happen to declare a variable of that type to have all these additional members allocated. So this is what it looks like. So new house, as you can see, the new house is my variable. So the new house memory is allocated. This is the style. These are the different integer data type and the double data type. And this is exactly how the memory is going to look like. And then how do I access individual members? Notice that I have 1, 2, 3, 4, 5, 6, 7, 8 members. How do I access them? So I access them with a dot operator. We call it member access operator. So if I want to access, let's say, number of bedrooms or the price of the house, I must use the dot operator with new house. So new house is my variable. And then if I want access, I must say new house dot. And when you put the dot, it's going to show you all the members in a drop-down list. You'll have access and you can actually populate them, you can view them, you can do the inputs, you can do all sorts of operations which we are used to. You can process them, you can add them to other members, and so on and so forth. And we'll see that one in a second. Here it is. For example, let's say you have new student. New student is a member of new student is a struct, and it has so many different members: first name, last name, course, on and on. And then new student.gpa. You can access that one, new student.gpa, and GPA is one of those members of that one. New student dot. So this is member access operator. It will allow you to access those members. You can populate them, you can display them like I stated, and so on and so forth. So I think I covered that one. Let's move on. So value of struct variable can be assigned to another struct variable of same type using an assignment operator. Now, if you remember, this was not possible in case of arrays. We try to do the same thing arrays because arrays carry the base addresses or address memory addresses. So we cannot assign one array to another array in an aggregate function by using an assignment operator. But here, in case of struct, this is another advantage. You can copy all the content of new student to this student. So this is actually a kind of advantage if you declare something as a struct. So this statement here literally means this. So this statement, student equals to new student. Behind the scene, what the compiler does, it copies the first name from one struct to another struct. Last name, GPA, everything is copied from one place to another place. So this is really, really wonderful that we can just assign all the data from one struct to another struct as well. So let's compare struct variable member-wise. No aggregate relational operations are allowed. So for struct, there's a limitation. I cannot just say if student equals to or one student is greater than to the new student. I cannot use those relational operators. If you remember, there are 6 of these relational operators: greater, greater, equal to, less than, equal to, not equal to, and equal. Equal is double equal. So because when I say I want to compare one struct with another struct, it has members. I must be more explicit. I need to say, I'm comparing their first names, or I'm comparing their GPAs, or I'm comparing their zip codes. What exactly I'm trying to compare. So that's why you must use individual members to compare. So for example, in this case, student.firstname equals new student.firstname and last name and last name. You have to do explicit comparison. You cannot do just the aggregate comparison for relational operations. So also no aggregate input-output operations on a struct variable. And again, that doesn't make any sense. If you're reading the first name, you have to use explicitly the first name. You cannot say, give me all the data. It's not going to tell us what data you're looking for. Are you looking for a GPA, or are you looking for the balance of the student? What exactly the value you're looking for? So that's why the no aggregate input and output operations are possible. Data in a struct variable must be read or written one member at a time. And that makes sense. That makes sense because if I want to display first name, I have to use dot operator, member access operator, and use the first name, use the course grade, and so on and so forth. So struct variables and function. A struct variable can be passed as a parameter by value or by reference. I'll be demonstrating that one. It's very easy to pass it on, and we have been passing on the arguments to other functions. It's kind of similar. And also, unlike arrays, a function can return a value of struct type. We couldn't do that with arrays. If you remember, in C++, you cannot return an array type of data back to the calling function. In case of a struct, it is possible, and I'll be demonstrating that one as well. All right, so take a look at this one. So student type is a struct. Student is a variable, local variable, we just create it. And then once you have passed this particular struct to this function, print student function, this is a void function, doesn't return anything. You have access to all the members of that particular student. You have access to the GPA, their test scores, and so on and so forth. Now this slide compares the difference between arrays and structs. As you can see, arithmetic operations not possible in struct. They are not possible in array as well. Array and struct, both of them. Assignment not possible in array, but possible in struct. We saw that one. You can assign a struct with another struct. We saw that one. Input and output is not possible. Comparison is not possible. Comparison means relational operations. Those 6 operators are not possible. And parameter passing, arrays are by default passed by references. By default, we cannot change that. This is the nature of the arrays. In case of struct, you can pass by value or pass by reference. The only difference is when you pass by reference, you use ampersand sign. If you pass by value, we saw in the previous slide, this is pass by value. If I put the ampersand sign right there with struct type, then it will become passed by reference. Function returning a value, in case of arrays, that's not possible. In case of struct, yes, we can return struct data type. And I'll be demonstrating that to you as well. 2 items are associated with the list, values, length of the list. So here, take a look at this particular struct, list type. List type is a struct. And inside the list type, we have list elements. And in fact, what we are doing here is we are creating an array inside a struct. And this is just the size of that particular array. So it could be size 10, for example, and this is the number of elements we are creating for the array. So this list element is an array. All right, so that's what it's saying. 2 items are associated with the list, values and length of the list. So this is what we are creating. We are creating an array, and we are creating how many elements it will contain. And so technically speaking, so you have created that array, that struct, and inside the struct, you have these elements. List elements is an array. And list length is just basically your the size in this case. And this is the name of your int list is the name of your struct. So if you want to visualize it, this is what it looks like. And if I want to access individual values, we know the list element. Let's go back here. List element here, or list length here, and list length equals to 0. And then we can access the 0th location equals to 12. And we can also do some kind of manipulation. We can increase that length to 1 by doing increment. This one is post increment. We can do increment, and the next element is 37. And then we can do increment, and we can continue to go in that sequence, assuming we have 1,000 of these list elements. So struct in arrays. So this is a simple employee type. It's very simple members inside the employee type. Now, what if I want to create an array of struct type? So here it is, employees 50. So we created 50 of these structs, and each one of these structs have these members. So each one of these have these members. For example, the third element has first name, last name, ID, and so on and so forth. And each one of these have their own arrays. So this is technically, this entire array, this entire struct can be created as an array as well. right there. And then you can actually structs within a struct. You can also create a struct within a struct. And I have a demo file available on Canvas showing it to you, and I'll highlight that demo file as well. Okay. So this is basically the summary is collection of fixed number of components of different types. Components can be different types called members. Instead of elements, we call them members. Accessed by the name. Struct is a reserved word. No memory is allocated because it is a definition or the declaration. So memory is allocated when the variable of that particular struct type is created. And dot member access operator used to access individual members of a struct. The only built-in operation in the struct are the assignment and member access. Neither arithmetic nor relational operations are possible on structs as a whole, as an aggregate function, but individual members, we can apply the relational operations as well as mathematical operations. So structs can be passed by reference as well as by value. So struct can return a value of return type. This is in addition to arrays, which we couldn't do it. Struct can be member of the other structs as well. All right. So now what we'll do some demonstrations. Before I do the demonstration, I want to share that I have bunch of demo files here. If you go to demo file here for Chapter-9, and if you open up, there are 3 demo files here. Just want to highlight these here for you. I'm going to just run one of them just to save time. Notice that here's my sample program 1, which begins here and ends over here. Here's my sample program 2. And notice that in the sample program 2, in the first program, I only have one struct here, one struct. In the second demo file, I have 2 structs. I have person info and I have education struct, 2 of them. In the second demo file, I also demonstrate, if you scroll down, I also demonstrate right here, when I create, I need to go to right here, when I create a person info, and person is an array. So this person is which is a type of struct, is a variable of struct. I created it as an array with 3 members or elements. And the third demo file right there, sample program 3, I have a bunch of structs. I have school, I have education, I have person info. Now, this one is slightly different because I want you to pay attention. And by the way, you can copy these and run them in your compiler just to test them out. And in the first one, in the school data struct, I have a school name, school city, school zip. Everything's pretty simple and straightforward. But I want you to pay attention on education struct. In education struct, I have number of years. Then I have something very strange happening here. I have school, my school. So school is a struct. So I have a struct within a struct. So this education data structure is calling or creating a member, my school, of this type. So this my school is created within another struct. And then third one, person info. This is simple and straightforward. These members, first name, last name, age, and city. But notice that education qualification. So I'm creating this particular struct inside my person info. And inside the education, there's another school. So 3 structs are kind of connected with each other. And access will be kind of a little bit longer. For example, if I want to access, and then also I'm demonstrating here, 2-dimensional array for person. Again, 1-dimensional array is similar, and we don't really need to use 2-dimensional array. I just wanted to demonstrate 2 rows and 2 columns. And if you want access, for example, information here, person info, and also qualification. Qualification belongs here, years, and it also will give you access to that one. So this is how you can do it. So you can see right there, I am accessing right there. So I and j, let's say I is 0 and j is 0, the first element in that particular matrix. And I'm accessing the qualification, which is under under here, under person info. Once I access the qualification, and then I access my school, which is part of education, then I also access the city, school city. So that's how you can use multiple member access operator. This might be confusing to you at this time. That's why I'm not going to ask you to use this particular method for project number 8, I believe. Project number 8 is much easier as compared to this. That's why if you just stick to the first program here, first sample program, you should be able to complete your assignment. So let me demonstrate. Just want to make sure I have the right one here. And all right. So I will be showing you this one here. So I copied my struct here, struct info. Again, you can name it anything you like. You can name it more meaningful. You can call it person if you like. And this is a very simple struct. It has first name and it has age, two of these members. Okay, so then I come to my main function. Here's my main function. Inside, I'm creating this person of this type, info type, which means this person has access to the first name and age. And immediately, I'm passing on this person data struct to read function. I'm passing on to read function. So take a look at the read function. So person is of this struct type. So I'm capturing this argument of data structure type, which means this one is a pass by value. This is pass by value because I am not passing by ampersand sign. If I put the ampersand sign right there, it becomes pass by reference. But I'm passing by value, which is I'm making a copy of this person and passing on over here. Then I have a couple of local variables, first name and age. Honestly, I don't really need them. And I'm going to show you, honestly, I don't really need them. I can comment these out because those are not really necessary. Then I have a local message here in reading the data in read function. Enter the first name for the user to see. And then I'm accessing the person when I put the dot, person dot, first name. So basically I'm accessing the first name, which is this member here, because this info has two members and I created person info. So then I can access the first name and read the first name, populate that in the RAM, in the memory. Do the same thing with the age. So once the data has been read, hopefully the data has been read successfully, then I can return this person. This was not possible in arrays because arrays are by default passed by reference. You don't have to return anything back. So that's why my read function is returning a struct here. So this person is an info type. So it is returned to the main function. When I return, I have to capture as a struct as well. So all of this looks kind of weird, that why I have person equals to read person, because I'm passing a struct here. And when it's returning a value, I'm capturing as a person as well, because the return type is a info type. Once it's returned, I have a local message here back in the main function, and then display the first name and display the age. Remember, the values were read in a different function, but they are being displayed in the main function. So if everything goes well, hopefully it will function. And it's asking for the name. Let's say the name is Tim. Let's say the age is 23. So here's my local message, reading the data in read function. Am I displaying the data in the read function? No, I am not. I'm displaying that in the main function. So I hit enter and it shows me back in the main function, name is Tim and age is 23. So that's how you can actually populate the data in one place, return that as person. And what if I do not? Let me make this one a void function just for the sake of argument, and I'm not returning anything anymore. All right, let me try running the code again. Let me just clean it up a little bit. And I don't need to return this one. And I'm just reading the data here. Let's see what happens. So here, oh, I have to change this to void. And because now I am not returning anything, I cannot capture anything. So let me run the code again. And asking for the name, I say name is Tim, age is 23. When I come back to the main function, take a look here. It's garbage. It's picking up the garbage from the RAM, nothing for the string. Why it didn't happen? Because I didn't return anything. Nothing was returned. The data was read successfully, but data was localized because this is a void function. What if I put the ampersand sign here? Ampersand sign here. If I put the ampersand sign here, I have to change my prototype as well. And then I keep the way it is and run the code. And name is Tim, age is 23. This time, everything worked beautifully. So either way, either you can pass as a reference, which I did, or you have to return as a data struct. All right, so hopefully in your code, when you are making your struct and for project number 8, this will make sense to you. And whatever makes it easier for you, you can use that way. Also, I want to demonstrate, I want to show you our project. So let me go back here and share my screen with you. So this is our project. So this project, I want you to pay attention because this project might take a little bit longer. I'm actually providing you the data. Data is only the name of the item and the cost of the price of the item, the only two items here. So it says write a local program for the local restaurant, show the customer different menu options, allow the customer to select more than one item, calculate and print the bill. So let's say the user wants only tea, so it will display 75 cents. If the user wants tea and breakfast, fruit breakfast, then you will add 2.4, 2.49 and the tea, and then you will add tax also. We'll see that the tax in the second page. So here it's telling you, you will use an array menu list and the struct is called menu item type. So it's exactly telling you what you need to create. And let me just menu item type. Let me see if I can copy it. It's not letting me copy the whole thing, but that's okay. Let me just demonstrate here. And before I go back, so the array is menu list. All right, so I'm not sure you can see my screen or not. That's why I'm switching. So in my case, I'll create menu item type. This should be type. And here is my struct right there. How many items do I need? I need a string, item name, and I need double price. That's all I need. Here's your data struct for project number 8. Then when you come to the main, and if you want to create a member of that type, so you have menu item type, that's your struct name, and menu list. Menu list. And this will be your array. All right. So again, if I want to, for example, access item name, so I can say menu list 0, first element, dot, and I can say item name. Item name equals, let's say T. And I'll copy this one. Actually, let's just type it, menu list. So the first element, which is 0th location, price. Let's say that price is 0.75, 0.75. Okay, so in your case, you'll be reading this data from a file, and I have the data already available. But if you prefer to read the data from a user, that will not be a very smart idea because it will take you a lot of time and a lot of testing. It's going to waste a lot of your time. So just read the data from a file. You will not be inputting the data here in the code. Now, some of you probably will struggle and you will probably put the data in the code as well. That you will lose some points, but it still will be acceptable. So if I want to take a look at this information, for example, just to see if it's working, and I can show it to you, add a space here and show me the price. And again, this is much, much more you have to do. I'm just here demonstrating how easy it is to create an array of that type, array with size 10, because we are assuming there might be 10 or maybe 100 items. So when I run my code, and you can see right there, information. Oh, I think menu item name, it's not displaying. Oh, actually it is displaying. So let me comment out this part here. I'm going to comment out this part just to read on the code. For some reason, it's not picking up the item name. Where did I make a mistake? Item name equals to this string item name. Looks okay. And it's not picking up the item name. Let me see. Let me try to figure that out. But the overall idea is that it should pick up the item name as well. And I'm assigning it correctly. And this is a string. Item name is a string. The variable name is the member name is the correct name. And I am picking it up successfully. There's no syntax error. So why it's not displaying it? Let me comment out this part here and put an ENDL here. And let me comment out these lines of code because we are not accessing those at this time. All right, let's run the code. Yeah, it is picking it up. And what happened there? So let me do this separately. I'm not sure what happened. It was supposed to show, and it did show separately, and now it is showing up. I'm not sure what happened. So it was supposed to show, and it did work. So this is how you can do it. But of course, you'll be adding functions, and I already demonstrated when you pass into another function, and especially when you're passing as menu list as to another function, it is automatically passed by reference. So then you don't have to use ampersand sign at all, and you don't have to return anything, especially when you're reading the data. Arrays are automatically available to you when you come back to the main function. So this project will take you some time. Let me show you the second page of that one. And this project will test your experience. So for whatever you have learned, I already showed you how to create a struct. I already showed you how to create a menu list. So it's telling you to read the data in a separate function, show the data in a separate function. Then on the second page, print the check in a separate function. So your check will be something like that. Make sure you have two decimal places. It's set precision, which we learned in chapter number 3, and make sure everything is right justified here. The numbers are right justified, and the labels are left justified, and you're adding 5% tax here. Okay, so you'll be creating 3 or 4 functions, and you'll be reading the data in different places and displaying your menu. And the user should be able to order items. So you'll ask the user, what item would you like to order? And user can order multiple items at the same time. So please plan to spend some time on this project. This project will take some time. And once you're done, this will be a great accomplishment for you. Now I'm going to show you where is the data file I have made it available to you. I'm just drilling down to that one. So let me share my screen. And if you go to our project, and you'll see menu data, project 8 menu data. And this is the data. notice that this is the data I recommend highly you read from an input file. To make it easier for you, I put the underscore. If you don't use underscore, then you have to use a getLine function. If you know how to use getLine function, then you can read spaces as well. Otherwise, just the way I have the data placed here, it will be much easier to read this as a string. And you say, how do I read it? Well, that's not very hard. You simply copy this code, go to your online compiler. And if you remember, I demonstrated that to you in the past. But very quickly, let me demonstrate once again. You can create a new file, input.txt, or any file name you like to create. Place your data right there. So this will be read as a string. This will be read as a price. So when you go to your main program, this time you're not reading the data from a person right here. You are reading from an input file. So somewhere here, you will say if stream in.open input.txt, that's your input file. And then I want to read it because assuming there are 8 items for int I equals to, I equals to 0, I less than 8. In our case, there are 8 items, but it could be more than that. You can use a while loop, not end of file. Actually, let's do that. That will be better because what if we add more items to while not in dot eof. So that would be better. Have a curly brace here. Then you want to start reading the data here. So how do I read the data? Let me show it to you. And you want to pick up the data right there. And then you want to pick up the next piece of data right here. All right, so we picked up the price. And then hopefully that will, and then we can actually copy these from here and put them inside the while loop just to test it, just to see if the data was read successfully. And yeah, let's go from there. Let's try it. And otherwise, we'll come back and add more things to it. It's not happy because I did not include the fstream library. Let me go ahead and use fstream library here. All right, should work now. So let's try again. And there it is. I picked up everything successfully. And just 2 lines of code, literally, and it picks up all. Now, if you add more items to your menu, it should work as well. Okay, I think this should be good start for you to start the project, and I'll see you in next week. Thank you. Bye-bye.